text mining process. What is a text mine? This is very important diagram for you, that what is a text mining process and what kind of data you will be having in it. So on the left hand side, if you see over there, you will have unstructured data or the structured data. The structured data is in the form of database, and the unstructured data is in the form of text over there. Okay, so you have to analyze, extract the knowledge from the available data sources. So it can be a text data or it can be a database over there. And then you have like you can have some software limitation. You have privacy issues as well. Sometimes you cannot access the data, especially like medical records. That is like privacy issues they have it. Okay. Or other like legal documents, privacy issues, linguistic limitations as well. And then we need the domain expert. Who is domain? For example, in the last slide, so the gene structure. So sometime the BI experts, they know the tools over there, but they are not expert into the domain. Domain means the medical terminology over there. What is a gene? What is the pasta? What is the part of speech? What is the natural language processing? So domain experts are important, and they need to work with you. And tools and techniques. So your duty will be to provide the tools and techniques for that one. Okay. And then you extract the knowledge. The basic output will be the context specific. So if you just extract the knowledge, that is not important, but it should be the context specific. According to the context, it should be valid over there. Okay, so the three-step the text mining process. So like for example, what the text mining process are they doing? So they establish the corpus. So I told you what is the corpus. Corpus is a set of the words basically, which is a file which is full of verbs or words. So collect, organize, and domain specific unstructured data. So you have to, the first step is to collect the unorganized structured data, and then create the term and document matrix. So you have to make a matrix for that one, introduce the structure to the corpus. You will give like a specific structure in the form of the matrix. You know matrix, what do you call it matrix in Arabic? Okay. Right. So yeah, the matrix will be then we extract the knowledge over there, discover the novel pattern from the DT matrix. Okay. So this is called term document matrix. TD means term document matrix over there, where the documents and terms are interrelated over there. Right. So in the first task, this is the elaboration of the first task, that the input to the process includes a variety of relevant unstructured and semi-structured data, such as text and XML and HTML, etc. over there. In the second step, the output of the task one is to collect the document in some digital format for computer processing. And at the end of the second task, what you will have it, the output of task two is to a flat file. Okay, with this file is called term document matrix, where the cells are populated with the terms frequency, that how many terms one term is frequently occurring over there. And some statistics you have to apply after the completing task number 2. And the task number 3, you will get the final output, and that output will be having a number of problem specific classification. You can put different algorithms on that one. As in chapter number 4, we had classification like trees, association like a priori algorithms, or the clustering models you can put and then visualize your output over there. So this is linked, this chapter is linked with the chapter number 4 as well. Now we go for like a text mining process. What are the exact text mining process in more detail over there? So as I told you, that establish the corpus. Corpus means a file which is full of words over there. Collect all relevant unstructured data. It can be from XML, it can be from the text document, even it can be from emails, web pages, short notes, and voice recordings. And then we have to digitize. Second, digitize means make it like in the form of digital form, standardize and collect it. Okay, digitize means it can be in ASCII values. So you know about the ASCII values. It is from 0 to 255. Okay, so from 0 to 255, all words are coming from A to Z, and 0 to 9. Okay, special character, hash, dollar sign, and all the special characters are coming over there, and even the space. So 255 is the replacement for the space. 92 is the ASCII code for the ABC capital, the small one, and for capital ABC 65, 66, 67 over there. But the question arises, what about the other languages? If it is not English, it's Arabic, Chinese, French, okay? So then for that, we have another coding scheme that is called Unicode, okay? It's not unicorn, it's Unicode. So Unicode is uni. So we have a Unicode for it. So Unicode, they have the codes for different languages as well. So one of my patent is on the Unicode, that how we can have different languages encryption for different languages as well. So place the collection in a common place, okay, in a flat file or a dictionary as separate files over there. So this is the first step in the data mining process. Second is a term document matrix. As I told you, this is a very much important step that you just like link the terms with the document over there. So look at this diagram and see that how the terms and documents are interlinked with each other. If you see this this column, so here you have all the documents. Document number 1, document 2, 3, 4. How many documents you have? In the term, what you have it, for example, the specific terms like investment risk. So this terminology is in document number 1 and document number 6 over there, right? Now see project management. So project management is in which document? The term project management is in which document?
2 and 4.
2 and 4, very good. Yeah, so it is in 2 and the 4 over there, right? Okay. Now the software engineering word, the term means the terminology. The terminology of software engineering is in which document? Document number 3. Okay,
and 5.
And 5. Okay, what do you mean by this? Then why they have increased the number? This is 3 and this is 2. Yeah, can anyone think on that one? Because it say 1 1. Okay, so it means so this is 1 and this is 1. This is 1 1. But here they have written 3 and 2. What is the reason behind it? Just use your common sense, please. Make your mind like more functional. No, think more. I give you some more time. This is a frequency. See, so it means this word occur 1 time in this document. This 1 time. This one is 3 times. So software engineering word come 3 times in this document number 3. Okay, and this software engineering word comes 2 times in this document, right? Now development. So this is 1 time. This is 1 time. Okay, 1 time. SAP 1 time. So this is called term document matrix. So you have to prepare. The next step is, so you have to write all the documents, okay, and then you have to write the specific words you are interested in it, okay, that I need this word, because this will make your concept development. See, the computer doesn't know about he has no idea what is inside this document, but to make a concept you need these matrices. For example, if you want like to make an assignment for business intelligence, okay, so and there are some terminologies like data mining, web mining, so you put business intelligence, data mining, web mining, text mining, okay, and then you say this document contains this 2 times, this document 1 time. So you make a document. For example, you take 10 documents, okay, and then make this matrix for you. So it will make this matrix is easier for computer to read, right? So this is very easier for computer to read it. By this way, you make a concept building in a computers. So create the term by document matrix. Should all the terms be included? Stop words, include word, which words you want to include, which you don't want to include. Synonyms means like synonyms means the different words with the same meaning. Homonyms mean same sounding words with the different meanings over there. Stemming means like dividing the different sentences into the different groups over there. So what is the best representation of indices, values in cells? Row counts, binary frequencies, log frequencies, inverse document frequency. So these are the different steps over there. In this, there's some more detail about that. For TDM is a sparse matrix. Sparse means you can easily go through it like by checking one by one. You know which column and which rows. So rows and columns matrix over there. How can we reduce the dimensionality of the TDM? The dimensionality means like more dimensions, more rows and columns over there in multi-dimensional arrays over there. Manually we can do it, and domain expert goes through it. You can check with the domain expert and it can reduce the dimensionality, eliminate terms with a very frequency in very few documents over there. So you can eliminate the terms which is not frequently occurring over there. Transform the matrix using a singular value decomposition. So there is another mathematical terminology. This is called SVM. SVM is a singular value decompositions. You can transform your matrix into single value decompositions. SVM is similar to the principal component analysis. Principal component analysis is another very good mathematical analysis tool which filters. Basically, these are like a filtering kind of techniques over there. So if you want to learn more about it, so you can search what is like a single value decomposition and how it works in mathematics and especially principal component analysis. And then we have the third process, extract the patterns and the knowledge. How we can extract the patterns and the knowledge over there. You can use the classification, you can use the clustering over there, and you can improve search recall, improve the search precision, scatter or gather, query specific clustering over there, association or trend analysis. Okay, so research trend identification in literature. In the literature, how they are being used over there. They are mining the published information system literature over there. Like we have MIS quarterly, Journal of MIS, we have it, information system research, we have it. So they covers 12 years periodics from, let's suppose, 1994 to 2005, or maybe in more years. For example, they have 901 papers are included in the study. Only the paper abstracts are used over there. 9 clusters are generated for further analysis. Okay, text mining application. What are the text mining application? So this is one of like how the MIS quarterly are doing. So they mine, they see the year, which year the papers are, the journals are issued over there. They put the author's name, they put the title of the journal, which title of the journal it is. It's a volume and issue number. Last time, remember, I practiced with you that from the case study extracted from the different sources over there. This is the author's name, this is the year published, and this is the journal name. And the pages we have it. Okay, so we have, let me have it, which page number from this page to this number, and the keywords, knowledge management, supply chain. So with the keywords, you can easily search the specific articles over there. And abstracts. So abstracts are also very important. If you read the abstract, you know what is inside the inside story of the papers over there. So now see the research trend analysis. Like for example, in 1994, what is the trend of the research? In 2000, what is the trend? And in 2005, what is the trend? So you have different cluster, 1, 2, 3, 4, and these are number. On the y-axis, you have a number of articles, and on the x-axis, you have the number of years over there. See, now see the trends are changing in all the different 9 clusters we have it. So this is one of the best application of the text mining to show you the trends over there. So if you go to the Scopus over there or the Web of Science, you can have this kind of trends, and they are using the text mining. So similarly, this is another one, different clusters over there.